we're gonna go ahead and start. That way, I am going to share my screen. That way, you can people later on can look at that. Okay, so let me go ahead share the screen. All right, can you all see my screen now?
Yes.
Okay, all right, good. So my name is Yanjun Abram, and I'll be with you this semester. I have been teaching statistics for quite a while. So, especially the weekend class, I was the one at the very beginning to teach the weekend class. At the beginning, we all go to the Trinity, River Center and then meet once a week. And then after that, we kind of transfer to the online meeting. And it turned out like an online meeting even more popular because, people don't have to rush for the traffic that way. So that's why we continue this one online. All right. So, and I also teach college algebra, contemporary math, business math, all the way to calculus. So I do teach all kinds of different subjects, but I usually tell students, say, hey, statistics is my favorite subject. The reason I say that because I also work in a statistical research office for 10 years. Okay, so I really use statistics in everyday's life. So, when we do the concept calculation or something, I will usually include some of a lot of real life examples. So that is the good thing. So that's why I always say statistics is my favorite subject, right? Okay, so let's go ahead and look at the syllabus very quick. Everyone should be able to log into Canvas, right? Canvas.tccd.edu. If you cannot log into Canvas, you have to call the college technical support, okay? Because I cannot get you logged in. But after you log in, you will be able to see the MindLab and Mastering in here. Okay, click the MindLab and Mastering. This is the one you will be able to access to the homework assignment. All right. You want to open the MindLab and Mastering. And once you open this one, it usually giving you the two options, one option or three options, basically. It will telling you, input the purchase code, or you can use the free, you can use the free pass for like, I think usually it's 2 weeks, okay? But you need to pay for that in 2 weeks. And then another option here is you can have a 18 weeks access purchase that one directly from Pearson, because this course is not a TCC plus course. That means when you pay tuition for this course, you don't pay for the MindLab access that way. Okay, so I think it usually costs like a 60 or 70 or $80 for the 18 weeks access. You do not need a full year; you just need a one semester. That is enough. All right. So, any question about this one, MindLab and Mastering? If you open this one, if you do not have a Pearson account, you're gonna need to create a Pearson account first, okay? And then you can go through the link in here. You do not need a course ID to enroll in this course. As long as you come here for the Canvas, you open from here, you do not need a course ID, all right? So that way, if you go through a Canvas, your grade will show on Canvas that way. So we prefer that one. So now you can come to after you set up the account, you can come to the assignment, and then you will be able to look at the assignment. You can even open the homework from here. Okay. You can actually open the homework from here, but you have to go through the Pearson MindLab and Mastering assignment first. All right. So those are the questions. You can do the question directly from here. But I usually, like to open a Pearson account so that way you can see the whole thing, right? That kind of thing. Okay, you can go to the MindApp and mastering, and then that way you can student link. You can start all assignment in here. Okay, so you can enter the assignment, and then you can see all the assignment in here already with the different due days. All right. That is the quick and easy way to access. Okay. Any questions about the course access? So
I don't know if you're gonna. Hi, I'm sorry. This is Ana Cajiga. I don't know if you're gonna get to it later, but I purchased the book, but I haven't been able to access it. It requested me for a code ID or a link from my professor.
no, that's why what I said is you need to log into Canvas in here and then open from here. You do not need a course ID. You do not need any link from me. That kind of thing. If you need a link, you need a course ID, you went to the wrong place.
Okay, so that will work for the book as well.
Yes. You buy the book, you also buy the course, the access code, right?
It gave me an access code. Yes.
Yeah. So you after you open this one, it will have three options. One option is use the temporary one, which is expire in 14 days. I don't usually recommend that one, but if someone waiting for the financial aid, you can use that one. And then, once you get a financial aid, you purchase that, because 14 days, if you don't update that, it might lose the assignment that you have complete that way. All right. And then the other one is purchase directly online. And then the third option is you input your code. If you already have a code already, you can input from here as well. So you do not need any additional link or any course ID from here.
Okay, I understand. Thank you so much.
All right, you're welcome. Okay, any other question about the access? All right, so because this course, like I keep saying earlier, this is not a TCC plus, so the access, so the tuition did not include the course MindApp access. Okay, if you in TCC plus course, the tuition they charge you, which is more than the tuition. They also include a TCC plus the tuition a little bit more, but usually it's 60 something more, or 70. I don't know how much difference, but they already include the MindApp math access. Okay, but if you buy it directly from Pearson in here, the price is I think it's pretty much the same. All right, and the college charge you and the price you buy directly from here is pretty similar. All right, we're gonna go to look at the syllabus here, okay? Because that's the most time people concerned about the syllabus. When you open this one, okay, I already got some email. Some people say, well, I saw there's 6:30. What is that? All right, 6:30 to 8:30. I have another course, on the weekend. Okay, so that is the other one for the support course. Okay, the support hour is not this class gonna be start at 6:30. All right. This class is still start at 8 o'clock, okay, 8 p.m. to 9:50. So just FYI, let you know. The most important one here is the grading scale. You can come back to here, look at everything on your own. But the most important one here is the grading scale, right? Canvas eventually will show the grade automatically. So if you have an 89.5, it will show an A. But unfortunately, if you have 89.4, it's gonna be a B. All right. So sometimes you just need a little bit effort to make an A. Okay. Homework counted 24%. So make sure you really need to do the homework on time. All right. This course is an accelerate course, so it's pretty fast. So you're going to do it every day. All right. So give yourself a early Christmas present that way. All right. So our course end October, I think 14th, something like that, right? Let me see. Yeah, end of October 14th. So, that is and this is September, only 1.5 months, okay? And then you're gonna finish one college level math, so that's really big deal, all right? So make sure you stay focused. Homework counted 24%, chapter review and quiz, that is 16%, and then each unit test is 15%, all right? So homework and the review and quiz, those are 40%, and then the unit test 60%. That way they will add up with 100%, all right? So if you want to see what the unit test look like, this is the unit test, okay? Due by Monday, September 11th. In here, unit 2 gonna be due by Thursday, September 21st, and then the other unit test due by October the 5th, Thursday. Last unit test, well, I giving you kind of one more day, supposed to be due by Friday, but I giving you until the very, very last day, October the 14th. So no more extension. I only leave myself one day, Sunday. I will work on Sunday. Yeah, I leave myself one Sunday to do you grading. So the grade gonna be due by Sunday night. All right. So when I say Saturday, I already giving you all my last minute. That way, supposed to be finished by Friday the 13th, but I giving you one more day. So absolutely normal. Extension for that, okay? Unless you have a medical emergency. If you have a medical emergency, want to extend the past this day, I cannot approve. You have to go to the dean. And then dean cannot really approve. Finally, I have to go through all the way to the VP, okay? So it's very, very complicated. Have to approve by so many people, very, very complicated procedure, that kind of thing. And you also have to have a document, because if you don't have a document, it will be really hard to approve, all right? So I really, if you have anything happen during the semester, talk to me. I will be more flexible during the semester, but not by the end of semester. By the end of the semester is out of my control, okay? So just let you know, we can work during the semester, but you cannot wait until last minute trying to finish everything. So I really strongly recommend you to follow the schedule, all right? But if something happened during the semester, let me know, all right? I will work with you trying to get a best out from that, okay? Any questions?
Yeah, I had a question.
Yes.
Okay, so when I'm opening up the My Lab through Pearson and I'm clicking on the assignment, it opens up like a separate window that's just blank and then triggers like a down. Then when I click on like the downloaded item, it won't let me open it.
Okay, what kind of browser do you use? You might have to sometimes Safari don't work very well with this one. We recommend to use the Google Chrome or Firefox browser.
I am using Chrome,
Oh,
and
okay.
yeah, it's like it's a blank screen here, and then it like triggers like download. Here's a document, a PowerPoint or something, I guess, and then I click on it, and then it won't open.
Okay, if you want to stay after the class, I can, and then you can share the screen with me. I can go through that one-on-one with you. How about that?
Okay.
Yeah, because we want to move on, instead of the technical troubleshooting, we want to move on to the class. And then after class, if you have those technical issue, we can try to see if we can figure it out later.
Okay. Okay,
All
thank
right.
you.
Any other question about the course so far? Okay, how about let's go ahead introduce yourself a little bit to the class, and then we're gonna go ahead and get started. Everyone want to go ahead and get started? Just tell your name, and then what kind of major do you have, and how many classes you taking? Something like that. All right. We have 21 people right here. So who want to go ahead? Go. Just briefly introduce yourself.
Hi, I'm Sophia Sheets. This semester I have two classes actually to finish my associates for my general studies. I'm taking statistics and biology.
Great, wonderful. And if you want to tell people what you do, during the week, like what kind of job you do or something, that'd be fun too. It's optional, not required.
Well, at this time I'm
Hello,
not
my
working. I'm
name's
a stay-at-home mom.
Elijah. I work in a pharmacy, taking two classes. I just actually finished my associates, and I'm going to pharmacy school next year.
Oh, great, wonderful.
Hi, my name's Melissa. I'm a stay-at-home mom. I'm taking 3 classes this semester, 2 at TCC. I'm taking statistics and American Sign Language, and then I'm also taking a literature course at UTA Arlington. This is my last class that I need to take at TCC, or that I can take at TCC, and then I'll be moving on to UTA for a bachelor's in English.
All right, wonderful. Next.
Hi everyone, I'm Sephora. I am taking 4 classes this semester at TCC and I'm a nursing major.
All right.
Hi, this is
I'm
Anna
Edna.
Castillo. Oh, go ahead, Edna.
Okay, thank you. I'm Edna. I'm currently working on my ADN to BSN, RN to BSN program at UTA, and this is one of the prerequisites I needed for it. I'm working as a nurse at Baylor and taking 2 other courses this semester.
All right, wonderful.
I am Ana Cajiga. I work as a teaching assistant in elementary level, and I am taking this class along with other classes at Texas Women's University as part of my prerequisites to sign up for the master's in speech and language pathology.
Wow, okay, great. Next.
My name is Nicholas. I'm still in high school actually. I'm taking around 5 classes, not at the same time, but this semester to get an associate's. So hopefully I can get some credit for college.
That's wonderful. All right. Anyone else?
Hi, my name is Shayla. I'm taking 2 classes at TCC. I'm going for mental health and human services, and I work at a middle school as an attendance and PEMS clerk.
All right, great. Anyone else?
Hello, my name is Hilda Luna. And I am 3 classes away from my associates, and I would like to go to a pathologist and transfer to UTN.
All right, wonderful. Anyone else?
Hi, I'm Sue McCall. I'm currently taking 3 classes at TCC, but I'm using these credits to transfer over. I am majoring in biology pre-med over at Abilene Christian University.
All right, wonderful. Anyone else?
Hi, my name is Tina. This is the only class I'm taking this semester, but I'm just wrapping up my prereqs for med school, and I work in the ER at Harris.
All right. That's great. Anyone else? Okay, all right. So we're gonna go ahead. We're gonna jump into our chapter 1. As I said earlier, this is a accelerated course, so we are getting start that way. All right. So our first section here, our first chapter is an introduction. Okay, introduction to statistics. And then the fourth chapter is pretty simple. It's only 3 sections. But since this is the fourth level of the statistics, so we need to learn quite a bit of the concept, okay? Just to let you know, there's a lot of concept in the first 2 chapters. After the first 2 chapters, we're gonna move to more calculation than the concept. So a little bit change in here, just let you know. So I usually recommend people say, you know, you need to read a statistic textbook at least once, okay? There's a textbook in here when you do the, see, when you go to the course in here, there's a text, okay? Pearson, there's a text in here, all right? I will show you, if you go to the MindNet and Mastering course form right here, you will be able to, you know, look at the assignment, and then okay, you're gonna have an assignment. You also have an e-text right here, okay? So when you click on this e-text and then you click again, this will open up the whole text. So I really recommend people read the e-text at least once, all right? Or if you have a paper one, that's, you know, you can have a paper one, but read it at least once for the text, because this one is kind of more like a, I said statistics is more like a science than the pure math, right? So if you go to the 4-year university, a lot of department, they have a separate statistical department than the pure math department, all right? So a little bit different than the algebra, pure math, that kind of thing, all right? So read a textbook once will really help. All right, so we need to know what is a statistic, right? And then we have to know the concept already, as I mentioned earlier. We need to know what is population, what is sample, what is descriptive, and what is inferential statistic. All right, so those are the concepts we need to know. So first, what is a data? All right. The data consists of information coming from observation, count, measurement, or response, right? So what is data? Like I said, how many students in our class? Well, that is a data already, okay? So, you know, data can be all kinds of different data, all right? According to the survey, more than 7 in 10 Americans say a nursing career is a prestigious occupation, okay? So now we said 7 out of the 10, right? 7 out of 10, we can calculate is 0.07 or 70%, all right? So those are the data, okay? So data can be, you know, contain the information from any kind of resource, basically. Can be from the survey, can be from the response, measurement, count, those kind of things, all right? Okay, so statistics is a science of collecting, organizing, analyzing, and interpreting data in order to make a decision, all right? So statistics basically involved in a lot of data. And because the data is so huge, sometimes, especially when I work in a research office, right? And the data is so huge that we cannot do that manually. So we usually using a statistical software. So those are the 2 software we usually use. Use SAS or SPSS, which is an IBM product now. Or sometimes in you know, some of the grade school, they're using R. R is an open source software, okay? But in this course, we are not going to use any one of these, because these are the commercial software, which is a little bit more complicated to handle a huge data set, all right? Our statistical data in this class will be very, very small compared to the real world. So we are not going to use this one. We're gonna learn the concept and the procedure. So basically, in this course, we learn the concept and the formula and the procedure, all right? If you want to use those big tools, you will wait until a little bit more advanced statistics, okay? And let me see, someone trying to get in something. No, okay. All right, so so the statistic is the science, and then we need to make sure we use this data to, you know, make a decision, right? So data, usually if you don't treat those data, it's called raw data, all right? It's called raw data. All right, so what is the raw data? Raw data is also called a false hand data. False hand data, okay? That is not treated, not manipulated. You didn't put it in any format, so those are the raw data. Raw data usually didn't tell you much of the information, so that's why you have a statistician trying to organize those data, and then you need to analyze, right? And then you need to be able to interpret those data in order to make a conclusion or make a meaningful information, to provide those statistical data. All right. So that is the whole statistic about. And you can see the statistic basically used in everyday's life. Okay. All right, so let's look at what is the data set in here. We have a two data set. One is called a sample, one is called a population. Population is the correction of all outcome, response, measurement, whatever you do that. Everything that are interesting, everyone will be count, right? If you count this population is the number of the people. That means if we say the population of state of Texas, well, now everyone live in Texas will be count. It doesn't matter which city you live in, Fort Worth or Dallas or Arlington, right? All will be count. So those are the population, okay? And then if we say the population of the US, now we have a 50 states.
I cannot hear you. I think your microphone is muted.
Okay, sorry, I don't know what happened. Can you hear me now?
Yes.
Yeah.
Oh, okay, great. So how long did that happen?
I heard the population part.
Oh, okay. I don't know why. Okay, great. I'm glad you pointed out. So for some reason the software just quick itself. All right. So population is everything, everyone in the area we're talking about. Okay. If we say the population of the Fort Worth city, so that's the entire city. It doesn't matter which street you live. Okay. If we say the population for the Texas, now will be the entire state population. Okay. It doesn't matter which city you live. And then if we say the population for the US, that means include 50 states. All right. So those are the population. If we set a population for the US, there'll be all 50 states of the people, okay? And a lot of time when we do the statistic, we cannot use the population because it's so large, it's gonna take a long time, cost a lot of money to do the, everything to everyone. So, a lot of time in statistic, we use a sample, okay? So what is a sample? Sample is a subset or a smaller portion of the population. So that is called sample, right? If you have 100 people and I cannot reach it to 100 people, I might just sample 10 or 20 of them, okay? So those are called sample. And we're gonna have a sampling technique later on. How do you choose your sample is also very, very important, okay? But statistic, we use a sample. Okay, so identify data set. We need to be able to identify a data set is a sample or a population, okay? So in a recent survey, 834 employees in US were asked if they thought their jobs were highly stressful. Of this many respondents, 517 said yes. So identify the population and a sample. Okay, so which one is a population? Which one is a sample? Can anyone tell me about it according to our definition?
834 is the population and 517 is the sample.
Not quite. Another answers?
The employees are the population. right?
Okay, only look at the fourth
I
sentence.
think
Don't look at the outcome. Don't look at the outcome. This
the
of
population
this,
would be, okay, I'm sorry.
yeah,
The
this is
population
the
would
outcome.
be the United States.
Yes, the population will be the entire US. Recent survey, and then the 834 employees are the what?
The
Are the
sample.
sample.
The
Or the
sample.
sample. Mm-hmm.
Yeah. Okay. So because look at the recent survey, so what kind of survey we conduct? We conduct 834 employees in the US. So the entire US, of course, is more than this many employees. Is that right? So the US population is the US, the entire US here is the population. So we only survey 834 employees. Okay. And what is 517 said yes? This is not a sample of the population. This is a sample outcome. You survey this many people and then this many said yes. So if we calculate this one right here using this yes divided by the total of the respondents, we got about 62%. So that means in US, 62% of the people say their job are stressful. That kind of thing. Okay. So now you have this survey sample, and then this many said yes. So now we have a little bit conclusion, right? So now we can say, yeah, more than half of the people's employees or workers in US said their job is well stressful, whatever they are, that kind of thing. So now we have this conclusion. We have this data to show people say 62%, which is more than a half, right? That kind of thing. Or you can say around like about 6 to 7 people out of the 10, say their job is stressful, that kind of thing. So now we have this information, okay? But if you're trying to survey everyone in US, what happened? Well, it might take you a long time. The only thing US do the population survey is what? Anyone knows that? The government do the survey every 10 years to the entire population. What do they call them?
A census.
A census?
Yes, that's the census. That's exactly right. So if you go to census.gov.gov, not .com, you can pull out all kinds of information. You can see who live in your street. And then if you want to open a McDonald's, you can see, how many McDonald's already there and what kind of area, income, characteristic. You can find all kinds of information from there. Okay. I did quite a few of the report in the past about the census. But this one take a long time to come up. Usually the census finish, you have to wait at least 6 months for the data to pop up there on the web, just for the raw data to pop up. So you can see, the census take a long time. That's using the population, okay? And they only do that every 10 years because the government spends so much money on census. That's trying to survey everyone. And this survey is also very important. The reason they don't use a sample, they have to use the population because they also involve the school funding, all those kind of government spending, they have to be as accurate as possible. Okay. All right. So when we use a sample, we usually not as accurate as population because it's a sample. Right? Any questions? Sample and population. We just learned two concepts, right? Okay. Now we're gonna have a more concept here. One is called a parameter, one is called statistic. So what is a parameter? Parameter is a numerical description of a population. I usually say, people say, you just look at the PMP, right? This is kind of the statistical name we use to describe the population. And the statistical name we use to describe a sample is called statistic, okay? So these both are the numerical description. This is just described for the sample in here, all right? Average age of all people in the United States, okay? And this is the parameter because all people in US, right? So that's the parameter, okay? Average age of people from a sample of 3 states. All right, so this is a statistic because this is from sample of 3 states, okay? So when we say statistic is used to describe the sample, all right? When we say the parameter is used to describe the entire population. So there's a little bit difference in here. So that's why we have to know what is the sample, what is the population, okay? All right, so look at this one right here. A survey of several hundred colleges, students, athletes in US found that during the season of their sport, the average time spent on athlete by student athlete is 50 hours per week. Oh, that's a lot. That's more than 40 hours of working week, right? That kind of thing. So describe whether the number whether each number describe the population parameter or the sample statistic. Okay, so a survey of several hundred college student athletes in the US. Okay, a survey of several hundred college student athletes. Is this a population or sample? Several hundred of them. This should be the what?
A sample?
The sample, yeah. Okay, this is just the sample, all right? So this is a sample, okay? This based on a subset of the population, so it's a sample statistic, all right? Okay, the freshman class at the university has an average SAT math score of 514. The freshman class at a university, okay? So this one is said the average SAT score is based on the entire freshman class. So therefore, this one is a population parameter. All right. So when it's a population, it uses the parameter. When it's a sample, it uses the statistic. All right. So the branch of the statistic. Now we talk about the statistic. We also have two different type of the statistic. One is called a descriptive, one is called inferential. Okay, basically descriptive statistic is very easy to do because you just organize, summarize, and display the data. You can use table, you can use a chart, a graph, or whatever to do the descriptive. All right, as long as you have a little bit software, it's very easy to do the descriptive statistic. The other one is called inferential. When you do the inferential, you have to be much more careful because you drop the conclusion about the population, okay? So inferential involved using sample data, okay? Using sample data, trying to draw a conclusion about the population, all right? So if you say these 3 people are all good at math, and you cannot just say, well, my entire population, everyone is good at math. Well, it may or may not true, depends on how you sample your data, okay? So sampling technique also very important. And plus, this sampling size is so small, okay? So you cannot just choose 3 people, say 3 people are so good at math, the entire population, it depends on what entire population you're talking about. Maybe entire population of Texas, right, are good at math. That may or may not true, okay? So the inferential statistic, you drop the conclusion about the population. So you have to be very careful. All right. This one is called the inferential statistic. Okay. So you drop the conclusion. Those are the inferential statistic. Okay. So can you tell the difference? Anyone? I've given you a descriptive statistic. Like I say, I have a 40% of people got an A, 30% of people got a B, 10% of people got a C, and so on. What kind of statistic is there?
Descriptive?
Descriptive, exactly, because I just based on the data, I don't do any conclusion. All right. 40% people got an A, 30% of people got a B, and things like that. Those are just really do a little bit calculation from the data. I do not make any conclusion. All right, so those are the descriptive. Okay, but if I say, female did better in statistics than male, that may or may not be true, but those are the inferential statistics because I dropped the conclusion. Okay, so just that you know the difference of these two concepts. Any questions? Okay, so look at this one right here. A study of 2,560 US adults from a funded of adults not using the internet. 23% are from household earning less than 30,000 annually. Okay, so that means if not online, so looks like a low income people, more low income people, right? More if well, I'm trying to make a conclusion already. Okay, so all right, let's stick with this one. 23% from household earning less than 30,000 annually is showing this data. So what kind of statistic is that? We have a 23%, 12%, 6%, 3%. What kind of statistic is this?
The inferential?
No, just this number. Just by this number.
Oh, a descriptive?
Yeah, just by this number is the descriptive. 23% of less than 30,000, household less than 30,000 income not online. So these are the descriptive. 3%, only 3% of 75,000 or more are not online. So those numbers, those percentages are descriptive, okay? But if I make a conclusion, I'm trying to make because based on this percentage, right? Now I'm going to drop the conclusion, say, lower income people have more people not online, not using internet. Now this will be the inferential, right? Because I drop the conclusion, say, more low income people are not online. Okay, so I drop that conclusion. All right, and my conclusion may or may not be true, depends on how well you do the statistic in here. Okay, if we correct all these data are accurate, now my conclusion will be correct. But if someone make a mistake on this descriptive or something, now my conclusion might not be true. Okay, so just kind of let you know the difference of the inferential and the descriptive. And guess what? That is our fourth section. Okay. Any questions? All right, so the fourth section is pretty straightforward. Okay. Let's look at the second section is the data classification. All right, so we learn a huge concept. We know the data, we know the sample, we know the population, descriptive, inferential. Okay. Now let's see what is the data classification, because the statistics involved in a lot of data. So we need to know what kind of data we have. All right, so there's called 4 levels of measurement. How to distinguish between qualitative and quantitative data. All right, so qualitative, that means it's kind of category. All right, and then quantitative is kind of like a number that you can add and subtract. Those are the quantitative, right? And then we're gonna need to classify 4 levels of the measurement. We usually like to use this is NOIR. So N is for nominal, O is for ordinal, I is for interval, and then R is for ratio. Okay, we will talk this a little bit later in detail. All right, so what is a qualitative data? This consists of attribute, label, or non-numerical entrance, right? Like an eye color. You have a blue eye, you have a brown eye, things like that. So the different color, right? Or sometimes the hair color, place of birth, or state of the birth. You might be born in a city, right? You might be born in Dallas, or you might be born, or you were born in Fort Worth or Arlington, whatever. All right, and the major, right? Everyone, we just talked earlier, everyone has a little bit different major. And you cannot just tell people, say, hey, my major is better than yours. It may or may not true, but if you major in something you do not like, right, that's not a good major for you. Okay, so you need to major in something that can support you, also you like. All right, so you cannot tell other people, say, hey, you need to go to this major or that major. Maybe that person doesn't like that major. All right, so those are the qualitative data. So basically, qualitative data, you cannot use the numerical number to measure them. Okay, or you cannot really tell which one is better than the other. Put it that way. It's just different category. All right, quantitative data, which is very easy to use the numerical number to describe them, right? So if we say the temperature today, well, today, good thing today is not 100 degrees. So if I say today, highest degree today was 98 degrees Fahrenheit, okay? Not Celsius, but Fahrenheit. That means it's hot, but at least we know it's not 100 degrees, but it said next Friday gonna be 101 degrees Fahrenheit. All right, so now you can compare the 98 and 101. Well, we know there's a 3-degree difference, right? So next Friday will be hotter than this Friday. So we can tell the difference already, okay? And then if someone said, well, lower degree gonna be just 80 degrees, I said, wow, that is good, right? 80 is much better than 98 degrees. All right, so we can tell the difference right away, okay? All right, but if some people say this is 32 degrees Fahrenheit, well, now you realize, well, 32 degrees Fahrenheit is a freezing point. Wow, that's too cold. All right, so those kind of things you can using the number directly to calculate. So those are the quantitative data. All right, and also the age. Okay, if someone tell me, say I'm 14, I'm 18, I'm 21, and I know the difference right away, right? So I know. Which one is, how many age difference, how many years difference are there? Okay, so those are the quantitative data. Okay, so let's look at this table in here. We have a model, we have a suggestion retail price. You can see the model here is called what? What kind of data?
The qualitative?
Yes, so the model here is the qualitative. The price here is the what?
Quantitative.
Quantitative, because you can use the number to describe. All right, okay, good. All right, so now we're gonna go to the 4 label of the measurement in here. Okay, so as I said earlier, I'm using the NOIR. All right, NOIR in here, NOIR. So we can now the 4th label is called a nominal. Nominal is a qualitative data only. Okay, so the qualitative, non-mathematical computation can be made. So that means you cannot add and subtract, no addition, no add or subtract. Okay, let's see. This one you cannot add or subtract or multiply. Or even if you do that, it doesn't make sense. Okay. All right, so those are just qualitative data. So those are the nominal. So what kind of things are nominal? Like the names, the label, qualifier, okay, birthplace, city name, category, okay, whatever kind of category you have, a major, those are the nominal, okay. And then we have a second one. So basically nominal, you cannot tell people, say which one is better than the other, because everyone has a different preference. Okay, so that's the nominal. Ordinal label of the measurement. So this basically can be qualitative, but can also be quantitative data. All right, so maybe a little bit confused. Is this qualitative? This even is qualitative, but this one, which one is better than the other. All right, So basically, ordinal, you can tell the difference. Sometimes you may not be able to calculate the number, but you can tell the difference. So for example, the grade A, B, C, D, all right, you know A is better than B, B is better than C, right? So if I say what kind of course grade you want to achieve at the end of the semester, of course you will say I want to achieve an A, all right? So we know A is better than B, B is better than C, okay? Even, we don't really discover a lot of detail, but we know A is better. Or same thing, if you go to the Olympic competition, you want to win a gold prize, okay? You know the gold prize is better than silver, and the silver is better than bronze, all right? So we know which one is better, okay? So you don't really have to have a number, but you know which one is better, kind of category. Okay, so fourth prize is better than the second prize, things like that. Fourth is better than second. So you have this kind of a range, kind of like the range. All right, and this range is better than this range, better than that range. Okay, so those can be an ordinary label. All right, this is top 5 TV program. Okay, American Idol on Wednesday was the most popular one. American Idol on Tuesday was the second popular one. And then Dancing with the Star was the third one, and so on. Okay, so even they don't have much of the detail, but we know which one is the top show, which one is the second top show, and so on. All right, so those are the ordinal. Okay, and there's a network affiliated in Pittsburgh, Pennsylvania in here. So you have ABC, NBC, CBS, Fox News, and things like that, right? So those are just the different name of the station. Okay, so those will be called a nominal label. Okay, the nominal. And then this ranking here, this will be the ordinal label of the major band. Okay, any question before we move to the next two? Can we identify these two differences between these two?
Yes.
Okay, all right, good. Okay. The third label of the measurement is called an interval. Okay, NOIR. So we have a NOIR. N is for the nominal, O is ordinal, I is the interval. So we are in a third one called interval. Interval label of the measurement usually is a quantitative data, okay? And the data can put in an order, you can do the calculation, you know the difference, that kind of thing, okay? So the difference, the calculation, the number calculation really making sense, okay? If I tell you today is 98 degrees Fahrenheit, and then tomorrow, gonna be 102 degrees Fahrenheit, things like that. So now you know the difference, okay? You know the difference. The difference here is 4 degrees, 4 degree difference. All right, so you can calculate difference, and okay, tomorrow will be hotter than today, things like that, okay? All right, so the difference between data entry is meaningful, okay? And then we can also say this can be ordered, right? We also know 108 is less than 102, okay? 102 is greater than 98, using the math symbol to express them, right? So basically, this data, you can add and subtract, you can also multiply. The only thing of the difference of this interval and the ratio is the highest level of the measurement, okay? Ratio, you can also add and subtract, you also can multiply. The difference of ratio and the interval here is the zero, consider the zero. All right, so how we treat the zeros in an interval label and a ratio label. Let's make it an easy one first. The ratio label of the measurement zero means a real zero. Okay, a real zero. So if I say I'm going to volunteer this weekend, all right? If I say I'm going to volunteer this weekend, that means the pay will be 0. So otherwise you don't call it volunteer, all right? So that is a real 0, okay? What happened in the interval label? Interval label sometimes also have a 0, but that 0 it just represent a position on a scale. Sometimes we call this is not a real 0 or fake 0. It's just a position on a scale, okay? Not an inherent 0. 0 does not imply none, okay? So this is sometimes a little bit extra in here. So basically, when we usually like a temperature, all right? When we say temperature degree, if I said 0 degree Fahrenheit, all right, 0 degree Fahrenheit usually is negative 15 degrees Celsius, all right? If I say freezing point, okay, so what is my freezing point? Anyone know what is a freezing point? Freezing point. All right, what's the freezing point here? Okay, freezing point in Fahrenheit is what? 32 degrees Fahrenheit is a freezing point, okay? But if I translate this one into Celsius, okay, it's 0 degrees Celsius. 0 degrees Celsius. 0 degrees Celsius is a freezing point. All right, so what does this 0 mean? Well, you know, look at it. I have a 0 right here. I also have a 0 right here. 2 of them are 0 because I use a different unit. It means something different. All right, this is 0 degree Fahrenheit. 0 degree Fahrenheit actually is negative 15 degrees Celsius. If I said a 0 degree Celsius is a freezing point, right? 0 degrees Celsius actually is 32 degrees Fahrenheit. It doesn't matter which 0 you use. Temperature still there, okay? Temperature still there. Then this temperature, you read this temperature as 0 because you read in a Celsius degree. All right, you read this degree as 0 because you read this one in Fahrenheit. Okay, and this one is below freezing point that way. All right, so this 0, you know, look at it. When I change a different unit, this 0 is kind of changed. So we call this is kind of a little bit like a fake 0, not a real 0. That's one way to explain this one. Another way to explain this one here is this 0 means temperature is still there, okay? It's just cold, but temperature did not disappear. Temperature still exists. So this 0 does not imply none, does not imply say, well, there's no temperature there. Yeah, it doesn't matter which 0 you're talking about, temperature is still there. It's just cold, right? 0 degree Fahrenheit, of course, is colder than 0 degrees Celsius in here. Okay. Any questions about this one? This one usually is the most confused one for all these 4 labels.
Is there another example to use other than the degree, the Fahrenheit,
okay.
and the Celsius?
All right. Okay, I can give you another temperature. Not temperature. Temperature is a typical one. I can give you another what I call the IQ score. Okay, so IQ score. IQ score. This sometimes we use IQ score to measure a person's some kind of ability or intelligence, whatever that way. Okay, so if someone tested on the IQ score test, if you're making 0, do you say this person have no intelligence at all? Can you say that?
No.
Well, if not, the IQ score will be just a what? An interval label of a measure, but not a ratio label.
Okay.
Does that make sense?
Yeah, I get it like that now.
Right, because you know this person
determine.
might bumble on the test, but this person certainly, I'm sure this person have other ability, intelligence as well, right? So the IQ score low, IQ score 0 doesn't mean this person doesn't have any intelligence at all. Okay. So those are called the interval label of the measurement.
Okay.
All right. Okay, good. All right. So that is basically, look at this summary for all these 4 labels of the measurement, right? Ordinal, nominal. Nominal is the most basic one. You pretty much put the data in a category only. There's no ranking, no addition, subtraction can be made from the nominal. Ordinal, you also put the data in a category. Now this one you can tell like arrange in order, so you know which category is which range, kind of like the range, which range is better than the other range, but you cannot add and subtract in the ordinal. Okay. Interval and ratio, you both can add and subtract, but you know, and still making sense, right? And you know exactly which number is better than the other. That way, even IQ score is an interval, but if someone tell people, you know, like Einstein said, they have a 140 IQ score, so we know that person is smart, right? Average people's IQ score is 100, but if you have a IQ score more than 120, we say, well, yeah, that kind of smarter, you know, a person. So we know we can add and subtract. That one still making sense. The difference here is the interval. You don't have a real 0. You know, this real 0 is kind of a position in a scale, or sometimes we call a fake 0. All right. Ratio 0 say, yeah, this textbook costs nothing, right? So it costs $0. So what does this textbook cost $0 mean? That means you don't have to pay any dime or any penny in there. So those are the real 0. Okay. So those are the ratio label. All right. Okay, so we just finished 2 sections already. So let's look at what is 1.3, which is data correction and experimental design. This section, if you want to do the project, usually in this short, if I have a 16-week class, I usually, you know, ask people to do a project that way, because 16 weeks, you know, they got enough time. After they learn the concept, they still have a time to correct the data, do the statistical analysis. But this 7 weeks is pretty short, so I don't really require you to do any project that way, because we don't have time. By the time we finish the concept, it's pretty much the end of the semester. All right. But this section will be good for the project if some people trying to do the project in here, right? So data correction, and then you know, experimental design, those kind of things. So how do you design a statistical study and distinguish between the observation and the experimental? But even we don't do the project, we still need to understand those concepts, okay? And then how do you correct the data? You can do the survey, or you can do a simulation, okay? You can do the online survey, you can do the paper survey, you can do the in-person survey. We have some students in the past going to the grocery store, right, and do the survey, you know. And some people work in a dentist's office, they already got the patient's data, they use those data, of course, they took the patient's name out. That way, we are not interested in a particular patient's information. They're just trying to use those to do the report. Okay, or you can simulate that way. All right. And then how do you do the sample? Remember, statistics use a lot of sample, right? So what kind of sampling technique you use? We don't want to create a bias sample. All right. So that is also an important part. Okay, so in order to design a statistical study, first you have to identify the variable of interest. So I usually tell people, say, this is your topic. You have to choose a topic, right? If you are major in the medical area, you might choose a medical area. If you're interested in sport, you can using the athletes, you know, topic, you know, things like that. So, you know, you have to identify the topic, right? And then trying to see develop a detailed plan for collecting data. If you like this subject, you have to know how you're gonna collect the data that way. And of course, you use the sample. You can use the population if it's possible, but most of the time we're gonna just use the sample. Okay, that kind of thing. And of course, you go to collect the data. After you collect data, you usually need to do a little bit descriptive statistics first. So the descriptive give people the information about your data, all right? Like I said, the age group or the gender or maybe the major or whatever data you have. So do a little bit descriptive statistics, all right? Let people get familiar with your data first. And then you're using the statistical analysis, and then to make the inferential statistic, right? So in order to make the inferential statistic, you have to learn the statistic technique we're gonna learn later on, and then do the statistical analysis so you can make a conclusion about your survey, about your project, right? And then at the very end, you need to identify any possible errors. Okay, so next time when people do similar project to yours, they can avoid those trying to eliminate those errors as possible. So that will be a good practice for design a survey, design a statistical study that way. All right, so one thing of the observation study, that means you only watch, okay? You observe the characteristic of the interesting part of the population. That means you don't do anything different, okay? You just measure. Research measure the amount of the time people spend doing valuable activities, like paid work, childcare, socializing, right? So some people say, yeah, I will go to the gym every week, every day, but do I get a statistic class grade improve? Well, I say that is my observation. If you spend too much time in the gym, don't spend enough time in statistics, you probably won't do well, right? So that's my observation. That's a kind of a saying that way, all right? So, but I don't do anything different. I didn't say, oh, you got more homework or you got less homework, right? I didn't change anything. I just observe, right? If people tell me, say, I go to gym every day, we do need to exercise. But if you go to gym every day, but not doing the statistic every day, that might be, in my observation, I might make a different conclusion, right? So those are the observation study, okay? That means you only watch. You don't do anything different to that person. All right, experiment, that means you treat something different, okay? The treatment is applied to part of the population called a treatment group, right? And then another one, you don't do anything, is another part of the population, maybe used as called a control group, okay? In which no treatment is applied. All right, so this one usually in FDA, right? The Federal Drug and Food Administration, they're trying to see which drug is effective. All right, so they usually let people, one group of the people taking the medicine, one group of people, do not take the medicine, and give them the sugar pill. The sugar pill sometimes called a placebo, right? And then they're trying to see, the drug is effective or not. Okay, so they have a control group or they have a treatment group. And sometimes the patient, they don't really know which group they will assign. All right. So they're trying to compare these kind of difference and then they're trying to see if a drug is effective or not. All right. So those are the called experiment, okay, because you do something different to the different group. So those are the experiment in here. Okay. All right, there's something called a simulation. Okay, simulation, you can use the mathematical model or using the calculator or software to do the simulation. All right, you can simulate randomly or something like that, so. And then there's another one is you can use a survey. As I mentioned earlier, you can have a paper survey, online survey, in-person survey. Those kind of things, you're gonna correct the data. Okay, those are the data correction. In here. Experimental design, if you're trying to do you have you have a control group, you have randomization, you have replication, okay? So you really have to document how you're gonna design your data, because people will look at that data. Will people, if you have an analysis, have a statistical outcome, people will first thing people will look at what are those data come from, right? Is your statistical data reliable or not? If it's not reliable, if your data are not reliable, your survey outcome won't be convincing that way. Okay. All right, another one is called experimental design, is branding. Branding technique, that means the treatment group and the control group, they do not know which group they will assign, right? So those are the branding. Double branding, that means even the daughter, daughter giving the drug, they still didn't, daughter and patient, they both did not know which one is which. So that's double brand. All right, so the experimental design, you have a random randomization, complete randomization, random block design, those kind of things. We don't really using the experimental design that much in here. If you want to, like I said, we not require you to do the project, so we're gonna skip that a little bit. We're gonna jump to the most important one here, is called a sampling technique. Okay, sampling technique is the key thing for this section. All right, this will be the one on the test, sampling technique. Sensor is a count or measure of the entire population. We talked that earlier, right? Sampling is a count or measure part of the population that is most commonly used in statistics. So that means if you have a sampling error, what happens? The sampling error is the difference between the result of the sample and the result from the entire population. So that's why census do not use the sample. Census, they want to use the entire population. All right. So they're trying to minimize the mistake, the error that way. All right. So if we sample not representative, if the sample we choose, the data we choose from the population is not good, the entire analysis won't be good. Okay, so that's why sampling technique is very, very important. All right, and the fourth one is called a simple random sample. Okay, simple random sample, that means every possible sample of the same size has the same chance of being selected. That means every member of the population has an equal chance of being selected. All right, so those are the simple random sample, which is a good technique. Okay, this one is a good technique as well. A simple random sample is a good technique. Okay. That means you can assign, what is a simple random sample? You can assign everyone a number, right? Like if I have 100 students or 100 classes, everyone sample a number, and then you just randomly go to the big pool, drop 1, 2, or 3 number. So those are the simple random. Okay, so simple random, the good news is everyone has an equal chance of being selected. The bad thing here is sometimes, if I want to select 2 female, 2 male students, okay, it's kind of very hard to have a simple random sample. You're gonna come out exactly 2 male and 2 female. All right. So that's why we move on to the other technique here is called stratify. Okay, let's see, what is a stratify? All right, so this is stratify technique here is you separate into group first, divide the population into group first, okay? And then you go to each group to randomly choose a sample from each group. All right. So for example, if I have this population here, I have a low income, I have a middle income, I have high income of the population, right? That usually how we group people that way. So if I have a 60% of the population are in the middle one, only 10% of the people in the high income. And I also have a 30% of the people in the lower income. Okay, so if I trying to do a survey, okay, if I trying to do a survey, like I said, I'm going to use 100 sample for the survey. Okay, so if I do the random sample, guess what? I might choose a lot of high income. I might choose like a 50% of the high income because usually high income people, they are more active, they participate in all kinds of activity, right? And these low income people, they usually are kind of, trying to make the end meet. They don't have time to, participate in a lot of activity. So this group of people might be less representative. I might pick like a 50%, might pick 50 survey from here. Okay. And if I do the random sample, that's the disadvantage of random sample. I don't have a control. Okay. If I do the stratify, okay, if I do the stratify, I can do this on purpose. All right. I will allocate my 60% of the survey go to the middle, 30% of the survey go to the lower income, and then only 10% of the survey go to the high income. That way this will be called representative. Representative of what? Of the population. Okay, so my sample data will be very representative to this type of population. So I do not oversample the high income and then there's sample on the low income. All right. So that is the really big advantage of the stratify. So sometimes we call this is proportion, right? If you have this population much bigger, we need to allocate a little bit bigger, allocation to here. All right. So that would be the proportion in here. So stratify technique can do this way. All right, the third method here is called cluster, okay? Cluster is divide the population into group. So the group is kind of one group is one cluster, all right? You separate into different group in here. But once that cluster got selected, the entire members in that cluster gonna participate, all right? So for example, this one economic zone, I put it into zone 1, 2, 3, 4 zones right here. Okay, within this county. And then if I go to randomly pick a zone, so if I randomly pick the zone 1, that means everyone live in zone 1 gonna participate. All right. So that means the cluster we separate into group, just like a stratify. But this one is you pick the whole group. You don't go to the group, pick 1 or 2 or 3. All right. So that will be the cluster method. Okay, the next one is called systematic. Systematic is very easy to do because it's systematic. All right, so kind of like a uniform. Okay, if you choose a starting value at random and then choose every case member of the population. So if I start with this one right here, randomly choose this starting number, right? And then I'm gonna get 8 every 100 households. So if this is number 86 and then add 100, it will be 186, and then add another 100, it will be 286, and add another 100. So I just very systematic, very uniform. Okay, add another 100 and then another 100, and then systematic, all the same, and go all the way down to the end. So those are called systematic. So, but basically, those are all good sampling technique. Depends on different situation. You can choose it differently. All right. The other one is not so good sampling technique is called convenience. Okay, convenience sampling technique is not good because if you have like a border control, right? If you only say, hey, I only work from 9 o'clock to 5 o'clock, I don't work anything after 5 o'clock. So what happened? Those drug dealer, they can smuggling drug after 5 o'clock. All right. So, you know, if we only check the goods, US import a lot of goods from other country, right? And then if I say, I'm gonna just, you know, randomly check the goods we import from 9 to 5, okay? Because I don't work anything past 5. Now those drug dealers, they know the you know, you don't check anything after 5, right? So that they can do something about it. All right. So those are called a convenient sample because convenience to yourself, but not a good for other things. Okay. And or sometimes the convenience only choose the member of the population that's easy to get. All right, easy to get in here. You can just say, hey, I'm doing a project and I'm gonna just survey all my sister, brothers, and that's it. I'm not going outside to survey anyone else. All right, so those are the convenient sample. Convenient sample technique, you have to be very careful because this might not represent the entire population. And then you use this data, you're trying to represent the entire population, right? So that kind of leads to the called bias study, not recommend, okay? Because you sample not good, so it will cause a bias study that way. All right, so that is pretty much about this chapter. Chapter 1 is all about a concept. Anyone has any questions? So basically today and tomorrow, you're gonna need to finish this chapter 1, okay? Monday is a holiday, so if you want to use the holiday, that's fine. But you know, basically today and tomorrow, you need to finish these 3 sections, all right? And then we cannot stop right there. We also need to move on to the 2.1. So I'm gonna go ahead giving you a little bit start of the 2.1 because we almost run out of time for today. So I just want to give you a heads up on the chapter 2. Chapter 2, you're gonna start doing a little bit calculation, but not a lot. You can tell chapter 1, we don't do any calculation, okay? Frequency distribution and a graph. So frequency distribution, you need to start doing the calculation, calculate the frequency, okay? The first 2 chapters still most of the concept, but this one a little bit frequency distribution. So how to construct frequency distribution include limit, mean point, relative frequency, cumulative, and boundary. So now you got more concept in here. And what is a polygon? What is an Ozai? What is a histogram? All right, so that's why I recommend to read the textbook at least once because it got quite a bit of the concept in here. So let's do that one by one in here. How do you construct a frequency distribution? Like I said, we have a 30 student in a class, right? And then the text 1 right here, we have a 30 people's grade, okay? When I submit a grade, of course, I submit everyone's grade, but the president don't really like to look at everyone's grade. So what the president like to look at is how many people make an A, right? How many people make a B? How many people make a C, all right? Instead of looking at everyone's grade, that's what the president likes to look. So you have to, for 30 people, right? You have 30 people, you need to go to counter how many people making an A. Like I said, if we have a 30 people and then 10 people making an A and then 10 people making a B, 10 people making a C, you know, for example, right? You have to go to count, okay? So those are the frequency. And then we're gonna do a graph, okay? So, and then we're gonna, you know, find out all kinds of different names in here. Okay. All right. So look at this frequency distribution. This is called a table. All right. And this a table here, we have a 1, 2, 3, 4, 5, 6 group. Okay. Each group, this one is called from 1 to 5, 6 to 10. All right. And then how many people between 1 to 5? We got 5 people between 1 to 5, right? And then 8 people between 6 and 10. So 5, 8, 6, 8, 5, 4. These are called frequency. We're using F for the frequency. Okay. All right, and then this is called classes. Classes is called a group. Okay, we have a 6th group. This is called a 4th class. The 4th group is the 4th class. All right, and then this one you can call is the 2nd class. This is a 3rd class. This is a 4th class, right? Is the 5th class and the 6th class and so on. All right, so this is kind of like a class. Okay, and the class, we have a class interval. Okay, the class interval, and then we're gonna also have a class width. All right, on the left side here is called a lower class limit. On the right side is called the upper class limit. So this is a 4th class. Lower class limit is 1. Upper class for the 4th class will be 5. Okay, and then if I look at the 2nd class, my 2nd class lower class limit is 6. My 2nd class upper class will be 10. So those are called the class limit. All right, the distance between the class is called a class width. Okay, so look at it. You use 6 minus 1, you got 5. So 5 is the class width. You can also use 10 minus 5. 10 minus 5 is also 5. Using 10 minus 5 is also 5. So you can use the left minus left or right side minus right side. But you have to use the different classes to find out the class width. Okay, if you use 26 minus 21 is also 5, right? You use 25 minus 20 is also 5. So that means one class can only one table. I'm sorry, one table. One table can only have one class width. Okay, one table can only have one class width, and the class width is the same everywhere. All right, it doesn't matter how you do the subtraction; they're always the same. So this table is not a random table; it's a very organized table in here. All right, the difference of the minimum and the maximum is called a range. Okay, so my minimum here is 1, my maximum here is 30. So my range will be 30 minus 1 will be 29. All right, so we usually need to construct a frequency distribution. So we usually like to put the classes between 5 and 20. All right, and then you need to be able to find a class width, determine the range, and then divide the range by the number of the classes, run up to the next convenient number. Okay, so this is if we giving you, okay, let's look at this data first. All right, if this is the data, this is 30 US adult. The data out of the pocket prescription medicine expense, right, for 30 US adult in recent year. Okay, so this is apparently this unit will be dollars. All right, so the first person, out of the pocket 200, right, and then we have someone is 400. Okay, so what is the range? Range, that means what is the maximum, what is the minimum. All right, using the highest one minus the lowest one. Okay, my highest one looks like a 40 or 405. Look at it. I just found there's a 405 right here. Okay, so 405 is my maximum. Let's see, and what is the minimum? Okay, so far I do 165. 165 is okay, 165. All right, so my range.
Wouldn't it be 155?
Oh, that's a 155. Okay, all right, yeah, 155. Okay, all right. So you need to go to find the minimum and the maximum. All right. So the range here. Okay, so the highest one is 405. The minimum is 155. So your range here is 250. Okay, your range here is 250. Range we're using R. R here is 405 minus 155. So that is 250. Okay, so if this 30 data, we want to give put it into 7 classes. So that means we want to separate this data, this 30 data into 7 groups. Okay, 7 classes is also 7 group. How do I arrange this one? So I'm gonna need to calculate the class width. Okay, class width. So what is my class width? My class width need to using a range divided by the number of the classes. So my range is 250 divided by 7. We have a 35.71. So we need to round up, always round up to 36. All right. So how do I do this table in here? Now I can go to do this table. My minimum is 155. Okay. And then this is my lower class limit. All right. I do not know my upper class limit in here. My upper class limit, I don't know. But I am going to look at my next lower class limit. I add a class width. So I add 36. So this 36 will be 191. Okay, so if I know this 191, my next label here, this will be 190 because you don't want to repeat. All right, now my next one, I add 36 again, so that's 7, 2, 2, 2 to 7. And then I know this one will be 2 to 6. Okay, so you keep going until you reach 7. The reason you need to round up because my highest one is 405. I have to be able to cover my last number. Have to be greater than or equal to 405. I cannot be less than or equal. I cannot be less than 405, right? Because I need 7 classes. All right. Okay, so that is how you do this one right here. Look at that. Start with 155, and then you add a 36. You got 191. Add a 36. You got 227. All right, so right here, 227, and 227, you add 36 again. So you got this one right here, all the way to here. So the last one right here is 371, okay? And then this one, 190, you can tell this is 191. So next one, this is 190. This is 227, so this should be 226, something like that. All right, you can kind of just do like that in here. And then sometimes you say, how do I calculate my last one? Well, my last one, you use 370 plus 36 because you do not need another group in here. So this added together will be 406. So that is how you calculate your last one. All right. So 406 is greater than 405. So that way we can have everything covered. Now we're gonna go to do the frequency, right? How many between 155 to 190? So we need to go to do the tally to calculate this frequency in here, right? You can go to do this tally in here. So how do you do the tally? Well, if you look at a data and then put a 1 bar right here, okay? For example, if you have a data, the first data is 200, right? So where the 200 go? 200 should be going to this one right here, the second class. So I put a bar in the second class in here. All right. And then go through this for everything in here and then until you finish the table and then you can come back to counter this tally. All right, this tally will be 3, 2, 5, 6, 7, 4, 3, and right here. Okay, that is how you count the frequency in here. All right, now you can see we start doing the calculation. Okay, how do I determine the beam point? Okay, the beam point of the class is using the lower class limit plus the upper class limit divided by 2. All right, so the beam point in here, 155 plus 190 divided by 2, beam point of a class. So that means it's the middle of that class. All right, 155 plus 190 divided by 2, that's the beam point of that class. All right. The good news is you only need to calculate the first beam point because the second beam point, the difference will be equal to the class width. So you can just use this one at a 36 and so on. All right, and then you can get a beam point for every class. Okay, now there's another concept here called relative frequency. Relative frequency, you have to use a frequency divided by the total. Okay, this sample size is the total. All right, and the total, sometimes we're using this big sigma, Greek letter, big sigma. sigma f. All right. Relative frequency is kind of like a percentage. You can think it's a percent. All right. If I tell you, say, we have 5 people making an A in a class, what does that 5 mean? Is it 5 out of the 100 or 5 out of the 10? Okay, if I have 5 people making an A out of the 10 people, that is 50%, right? It's much better than 5 people making 5 out of the 100 will be only 5%. All right, so you need to use the frequency divided by the total, that giving you the relative frequency or the percentage. Okay, and then we also have a cumulative frequency. Cumulative, that means you keep adding up together until the end. All right, the last number is equal to the sample size n. So that's accumulate all together all the way down. All right. Okay, so let's look at this one right here. How do we calculate this table, cumulative and the relative frequency? So this is the class we have earlier, right? So that is the class. This one is the class in here, and then we have a frequency, and then we're gonna calculate the beam point. As I mentioned earlier, you don't have to calculate this beam point one by one. You can just calculate the first beam point, and at 36, you can get the next one, okay? But relative frequency, you do need to calculate one by one, all right? So 3 divided by total, which is 30, okay? Give you 0.1, and then each one divided by the total, giving you the relative frequency, all right? And then this is a cumulative. Cumulative, you always keep adding. So the cumulative frequency for the first class, I don't have anything to accumulate, so that's still 3. But the second class, I already have 2 more in here, so I need to have using this 3 add 2 more, you get a 5, right? And then 5, I have another 5 right here, so I need to add them together to get a 10. 10 plus 6 here, you got a 16. 16 plus this one in here, you got 23, and then we have to keep going. All right. I think that was a little bit more earlier. Okay. Yeah, so that is this one right here. All right, the beam point, the relative frequency, and the cumulative frequency in here. Okay, so if you add this, okay. All right, a little bit graph in here. So graph of the frequency distribution, I think, let me see if we have enough time to go through this first section. It's more than what I'm trying to do. All right, okay, we can finish that. Frequency histogram. Okay, this is a bar graph, and what is a frequency histogram? Is a bar graph without a gap. All right, so this kind of bar graph without a gap is called the histogram. Okay, if you look at this histogram, I can kind of think this looks like a roughly symmetry, right? Not perfect, but roughly symmetry, because this is kind of going up and then coming down. Put a little bit more inside. A little bit data, a little bit kind of going up and then coming down that way. So roughly symmetry. All right. So those are the data we're gonna have. We prefer that data on. All right. And then the class boundary. So because the consecutive bar of the histogram must touch. Okay. So you using the class boundary instead of the class limit. So now we also have to now calculate what is class boundary. All right. Construct frequency histogram. We use the class boundary in here. So the class boundary, you usually just add or subtract 0.5. Okay, so let me see. Yeah, add or subtract 0.5. Look at it. The first class boundary on the lower class limit 155, you minus 0.5. So you got a 140, 154.5. Okay. And then on the upper one, you add a 0.5, so you have a 190.5. So now, if you look at this one right here, if you look at this one, these two are the same. These two are the same. These two are the same. Okay. So if you use this one, now you don't have a gap. All right. So the first one right here, okay, 154, and then 190.5, look at it, 190.5, you connect to the second class. And then this second class, you connect to the third class. All right, connect to the third class. So those are the graph without a gap. So those are histogram. Okay. Frequency polygon. Okay, so what is a polygon? Polygon basically is a line graph. This is a line graph. A line graph is called a frequency polygon. All right, a line graph, you just extend the, one to the left, after this is just the data point. Okay, and then after this data point, you extend the one to the left, one to the right, and you don't have anything on the left or on the right. So that's starting and ending at 0. So those are line graph is called polygon. Okay, so look at this one right here. If I want to construct a polygon, I will just make a 3. First class is 3, right? So where's the 3? 3 is right here. Okay, so that's the first point. The second point is 2. So 2 is right here. All right. And using the class beam point for the horizontal line. Vertical line is always a frequency. So this one using the beam point. So that's why we need to calculate the beam point. And then we just extend the one to the left, one to the right. And we don't have anything. We don't have anything to the left or anything to the right. So that's why it has a 0. Okay. So those are called the polygon. Basically, it's just a line graph. All right, relative frequency histogram. So what is a relative? Relative is a percentage. Okay. So basically, it's the same graph as the frequency. It's just using the percentage for the relative. Usually, graph will look at the same as the frequency histogram. All right. You're just using a different scale on the vertical. That's it. All right. So that is relative frequency histogram. Okay. Basically, they have a same graph. That one. The last one here is called Ozai. Ozai is the cumulative frequency. Okay, this is a cumulative frequency. It's called Ozai. So the Ozai graph is always keep going up or stay the same. It never go down. If we go down, it's a wrong Ozai. All right. So this one is using the upper class boundary on the horizontal. Vertical is always a frequency. Okay, this one is cumulative. And the last number on the Ozai is equal to the total number. All right, so that is all the graph we have for 2.1. As you can tell, we got go through a lot of concept for this, just chapter 2, just 2.1, right? So that's why I really recommend you to read the textbook at least once to go through all these concepts first. A little bit calculation, but not overall, not overfilm of the calculation, but you do have a lot of concept. All right, so that is all we want to talk today. The rest of the time I will reserve for Q&A. Okay, and I'm also gonna stop recording. Any questions?
Yes, I have a question. Will your presentation be available for us? The PowerPoint?